So let's get started. Today I'm going to go over this move zero problem. So let me try to understand it. Given an array, integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. So basically it is given an input is an integer array, and you're going to output the same integer array with all the zeros at the end, maintaining the order of non-zero elements. And also the constraint is that you need to modify the array in place rather than use an extra space to store it. So let's go to the matching stage. For this problem, what comes to my mind is some sorting algorithm like the bubble sort that you kind of move something. For example, the bubble sort, you move the smallest to one end and go so on and so forth. But that is a O of n square algorithm is not efficient enough. And so another thought about that is there's some function of the Python list that we can get some idea. For example, the pen or the pop. So we can pop an element at certain index. So this problem can be done like with I go through all the elements one by one, and when I meet the zeros, I'm going to pop it out, and then append a zero at the end. That could work, but the case is that the pop function itself, it has a time complexity of O of n. So basically, it is still the same as the O of n square algorithm. So the goal is that whether we can limit the for loop to a single for loop rather than a nested for loop. So another solution that may probably work is that we use pointers, 2 pointers. So one is for the non-zero elements. So the place for the non-zero elements for the position of non-zero elements in the new array. And the other pointer for going through the list. So basically what that means is that I have one pointer that will record the non-zero elements, the position where they should be put in a new array. So every time I go through the array through the other pointer, when I meet a non-zero element, I will copy that element to the position that they should be put in, and then go through the entire list. After that, we can set the end of the list, set the end part of the list to all zero. So I'm going to do that because it has the time complexity of all of n. Basically, I just need to go through the list twice, so it's still all of n. So the first thing I'm going to do is create a slow pointer and set it to 0. And so a forward for loop to go through the list. So basically, I'm going to check if current element is not 0. I'm going to set set the nums of the slow pointer to be the current element. Else, if it's 0, I'm going to continue the for loop. So after that, I'm going to set the latter part of the list to 0. So basically, it's start with after I set it to current, and I'm going to update slow pointer. So start with slow pointer to the end of the list and set all the elements to 0. So I'm going to do this. So create a slow pointer called set it to 0, and I'm going to implement a for loop. So for I in range length of nums. So if the current item is not 0, which means if nums I is not 0, I'm going to set the nums slow pointer would be the nums of I. And then I'm going to update the slow pointer. The slow pointer plus equals to 1. And then, so else continue, I don't need to write that. So after this for loop, I'm going to set the latter part to 0. So for I in range, I start with slow pointer and the length of nums, and step is 1, and I'm set all the things to 0. So nums I is equal to 0. And then I'm going to return nums. Or it says don't return anything. So that's probably it. So I'm going to copy this to here. Hope it will works. It works. Woohoo! So that works. And as you can see here, I use 2 for loops. So my time complexity will be O of n. And I use a slow pointer, so I use all of 1 extra space. And I think that's pretty much it. And thank you.